Hi, everybody. My name's Chris Chapman. I'm the SVP of Software Development for MacStadium. We're excited to be here at Jenkins World and DevOps. We've been here several years, 4 years, and obviously it's getting bigger and bigger every year, so we're always proud to be a part of it. In the audience, show of hands, how many of you guys have any experience or deal with Mac or iOS builds right now? Oh, that's pretty good. How about Kubernetes? Okay, we'll walk you through it. Well, today I'm going to explain what MacStadium is briefly, but then really get into what we're proud of launching, which is Orca, and that is orchestration with Kubernetes on Apple, and we're going to dive into that soon. First, let me explain who MacStadium is. Some of you or all of you may have heard of us or not, but I want to give you a quick overview. We're basically the enterprise-grade cloud solution for iOS and Mac app developers. We're purpose-built to help scale and deploy so you can build and ship faster with secure, scalable infrastructure. You can think of us as the AWS or Azure, but on the Apple side of the world. The big trick to what we do is we take what is typically considered a consumer-grade product, a single power supply sits on your desk, and we put a lot of proprietary racking and stacking around it, as well as services and expertise that turn it into true enterprise-class infrastructure that we scale around the world in data centers everywhere. What we do beyond that is even add virtualization so that it becomes more deployable and scalable and secure. So you can see here from this drawing, it allows integrations with your own customized firewall. You have a hypervisor layer. We connect high-speed NVMe flash storage so you can scale your storage above the internal drive of the machine. And we make it truly scalable and redundant like a cloud should be. And the reason we're doing this is, as many of you know who deal with iOS and Mac builds, Apple's going to make you build different. And that's generally a good thing for creativity, and it's generally an annoying and terrible thing for how you have to deal with dev and dev pipeline and consistent, predictable builds. So our happy customers are the ones that put the headache of managing the hardware and the infrastructure behind them and come to us so that we can help them focus on what they're good at, which is creative builds. You can't go to Azure and AWS and spin up a Mac VM. That's just not an option. They're tricky to set up, and as you all know, macOS doesn't make it simple or easy to layer on pieces and parts. And as your team scales, this becomes quite a challenge and really focuses you in a different direction than what you were trying to focus on. So we find that once we get folks set up and they start going, and the reason we're here is they rely on CI/CD platforms like Jenkins. That's pretty popular for folks that use us. It becomes a critical part of build and test. And we have tons of deployments right now with this that currently use VMware and bare metal Mac to use with Jenkins. And what we do around that is help deploy and configure it. But internally, as I brought software development to MacStadium, we decided to see if we could engage our community with the tools that we have in our own development shop and provide those out to our customers, because we know as developers how we like to build, and we think that's how others would like to build as well. So my team internally builds with Docker tools. We write a lot of code with Docker, and we use Docker for Mac, which is Docker on Mac, but Linux containers. We then deploy those Docker containers with Kubernetes. Based on the show of hands, just to give you a generalized idea, Kubernetes is what allows you to scale and deploy your container loads across data centers, across clusters. So it basically makes the thing you build in one container very easy to use at large scale without having to do a lot of work and a lot of thinking. And we thought, well, if that works for the way we build code, we could translate that into Mac and iOS builds and make it the same for them. But there are definite considerations and concerns around that. When you look at it, you go, well, why would somebody want to cram a giant macOS into this box? That's not a real Docker image. And you're going to layer it on top of Kubernetes, which is just going to crush this poor Mac and make it pitiful. And when we first started, that was true. That is what most folks run into when they try to add these technologies together. But with some innovative work and our custom infrastructure, we were able to do this successfully, and we were able to put controls around these things in a way that makes sense. So what you see here is kind of an overview of how our interface works from the software layer. You have virtualization platform built on top of our hardware stack that has Kubernetes as a namespace driver. And then in those namespaces, you have your normal Kubernetes pods, you have API CLI UI, and then you have an image management system. So basically what that gives you is a way to check out images, drive them, and orchestrate them with Kubernetes. And your experience with Kubernetes isn't particularly relevant to being able to use the system here, because the CLI and the UI will help you orchestrate it very simply, but there's also that sandbox space if you want to get more complicated. All this adds up to what you see a lot of folks wearing on your shirt, and our friend Mr. Whale at the front here. We are releasing Orca today for GA. It's been in beta for a while, and we're very excited to have it out. So come one, come all. I'm going to go into how it works for a minute, and then I'm going to hand it over to my colleagues here who did a lot of the work so they can show you it in action. So the structure of this is a little different from how you're normally going to use your Mac hardware. We actually connect the hardware to the SAN and then put our virtualization Orca layer on top of that, and then put your containers on top of that and orchestrate it all with Kubernetes. But what this gets you down the line, and as you start getting into more complex builds or builds with your other build teams, is all the tools and control systems like YAML, like Terraform or Ansible, sort of the infrastructure as code concerns that you can do with those types of systems, you now can do with Apple OS. The other advantage is that we've created an incredibly lightweight and an incredibly scalable system that is very performant. Typically, once you get past bare metal and you start working on automation and virtualization, you start to suffer from loading extra things on top of the machine, and you can get up to a 30% decrement in bare metal. So on the plus side, it's been easier to build. On the minus side, your builds are taking longer, which is not what anybody wants. With Orca, our beta customers have seen that virtualization tax virtually vanish. And the way we implemented Docker lightweight containers on the infrastructure is a big part of how that happens. The goal is to give you an interface that's very simple and easy to use so that you can connect to your environment simply. You can create your virtual capacity on demand with simple commands, and then you can control your builds and get out. Because the ideal is to spend less time bothering with the infrastructure and more time focused on your code. And that's what Orca does generally, but to make it even stronger, we brought these capabilities together with Jenkins. So we have Orca plus Jenkins today. So in addition to Orca itself, we're also open sourcing Jenkins plugins that are specifically designed to drive the Orca infrastructure. And again, we're going to show you that today, but we think it makes it even easier and even simpler to use. So let's get to the good stuff. The guys that are here with me, I have Taylor Moss. He's my lead developer for Orca. He's been with me for a while. He's a big Docker and Kubernetes guy. He's a Mac infrastructure expert because that's his job. And on the side, he's kind of a binger, a gamer podcast. So if you like gamer things, he's the guy to talk to. And then I have Ivan Spasov. He's with ST6, who works on all our integrations and plugins. He's definitely a super strong software guy. He's going to be who you see on the Jenkins plugin as the maintainer. He's really familiar with CI/CD as DevOps goes, and he's going to retire and be a soccer player someday. So without further ado, I'm going to go ahead and hand it over to Taylor. What he's going to do is basically walk you through running a live Orca cluster right now, and then when he's done, Ivan's going to show you how to add Jenkins as a layer on top of that and make it all work together. So here you go, Mr. Moss.
As Chris said, I'm the lead developer on the Orca team here. Orca is a really great way to manage and scale your Mac VMs on Apple hardware. It provides an easy and pretty performant way to manage those macOS VMs. it runs as a web application also inside the same Kubernetes cluster that runs on that Apple hardware. So we're giving you 3 ways to interact with your Orca cluster. First, you have your typical REST API. It's really great for developing integrations like our Jenkins plugin. Secondly, we have our CLI. So if you're a developer that likes to live in the terminal, you'll be familiar with our CLI. It has 2 modes, an interactive mode and your typical just pass flags in and be done with the command mode. That's good for scripting. And finally, we have our UI. And it's a great visual way to interact with your cluster. It presented to you through the browser. And one point I'd like to make here is that the UI is a simple and easy way to get going, but it also drives home the point that you don't have to know Kubernetes in order to use Orca to spin up your macOS VMs. So there's 2 pieces of terminology that are really helpful to know before I dive into the live demo here. We have the concept of the node, which is the physical Mac hardware. It's also literally a Kubernetes node. It's 12-core Pro in the instance I'm about to show you. And then we have our Orca VM, and this is the encapsulation of, the entire virtual machine. It runs in a Docker container, and it's encapsulated by a Kubernetes deployment or stateful set, if you're familiar with those terms. So another important term is our base image. This is like our VM template. This is your primary disk for your virtual machine. It's where your data is persisted. It lives on highly performant shared storage that's accessible by any machine in your Orca cluster, which brings me to my next point, your running image. So your Orca VMs are ephemeral by default. It's alive, the data persists only for the lifetime of the Docker VM. So if you're familiar with Docker containers, it's a similar concept. The ephemeral data is stored on high-performance NVMe drives that's internal to the Mac hardware. And utilizing this and the shared storage gives us a great combo of performance and scalability. This leads me to, I'm sure a lot of you are thinking, well, how do I save my VM data if these VMs are ephemeral? And we have a few ways of doing that. So we have Orca image commit, which is modify the original base image. So you start fresh in a cluster, you have your original base image, you've made changes, you've set up Xcode, installed a few scripts, and you can modify that original base image with Orca image commit. And from there, you have Orca image save. And with the Orca image save, it's a great way to go ahead and spin up additional templates. So you've gotten your kind of your core down for your CI processes, and you have different flavors that you'd like to save and then use for new Orca VMs. So I'm going to go ahead and jump into the demo here, but bear with me while I switch screens. That. All right, so I'm going to go ahead and start with our UI, and the first step in getting an Orca VM created is to create a VM configuration. So I'll start by giving that a name. I'll select my CPU core count. This is your hardware core count, and Orca is doing a pretty good job of the logic on the back end. It manages CPU affinity for performance, so your VMs aren't jumping around cores and then you're getting cache misses and losing performance. So I'll go ahead and give this machine 12 cores, and this is 12 out of the 24 logical cores that I have available on this Mac Pro. vCPU, I'll do the same, and you can tweak this based on if you have multi-threaded workloads and you want 12, or you can then also move to 6 and match the physical cores on the machines for less multi-threaded, more single-threaded performance. I'm going to select a base image. This image is something I've uploaded to our shared store. So I've successfully created a config. Nothing has happened except for the configuration data for that VM is saved. Next step is to go ahead and go deploy that VM. And while that's happening, I'll move over to the CLI and show you that these are kind of a unified view into your cluster. Voila, you can see the VM is up. It'll take a second before I get connection information. I'm sorry? Oh, yes. Let me see if I can get you a different color. That is that better? There we go. Zoom in a few more times there, I'm sorry. So there's our first machine, the config I just created. I'll go ahead and spin up additional machines off of that config. And one thing to note here is that I won't pass in a node name, so it will round robin to the next available machine. We have the ability to attach install media. So if you wanted to start with a blank disk and attach your Mojave installer ISO or Catalina, you can do so here. This machine should be running now, so I'll go ahead and connect to it. Our second machine was successful there. Well, I thought it was successful. Give me 1 second here. I used the wrong port. Mid-boot here, and while we're doing that, I'll go ahead. Oh, here we go. So I can go ahead and log in, interact with this machine. We give you a few ways out of the box to connect to these machines. We provide a VNC server that runs outside of the virtual machine, so you can connect to it and set it up before you've had the chance to set up screen sharing or SSH access. And once you've done so, good time to go ahead and commit to your original base image so you have connectivity over your typical routes like SSH for the Jenkins plugin. And while I'm on this machine, I'll go ahead and purge, which will bring down all the VMs that I've run off of that configuration. So our VM functionality, we have your standard stop, start, suspend, resume. You can clone your VMs, move them from machine to machine, and when you clone the VMs, they will actually retain their ephemeral data for the lifespan of that clone. So if you've made some changes and you'd like to make a few copies of that in the meantime, that's a good way to do that. We have the ability to scale a VM that uses the Kubernetes scheduler to spin up as many VMs as the machines will provide resources for. This is mainly bottlenecked by CPU and memory availability. So you can run probably up to a machine per core on these machines. They won't run well, and we don't recommend it, but you can do that. And then finally, I'd like to show you just real quick a brief demo of our Kubernetes sandbox functionality. And this is where you can see that the Orca cluster is running on top of a Kubernetes cluster. And the concept behind this is that you can run whatever arbitrary resources you would like to deploy alongside your VMs and then access them from the same network that your VMs are running on. And it's a great place to spin up things like Jenkins masters. So I've just spun up a Kubernetes configuration, and this will give me access to my sandbox functionality. I have a hello world example that I'll spin up, and then I'll show you how to access that. So my Hello Kubernetes example spun up. It was assigned a VIP, and I can access that at 10.10.10.90 now, and it'll give me some information about the cluster. There we go. This page would be accessible from any of the machines that I spun up had I not destroyed them before showing you this. And that's it. You can run any resources that you're typically running on Docker and Kubernetes alongside your macOS VMs. And like I mentioned before, great place to utilize Jenkins. So with that in mind, I'll go ahead and hand it over to Ivan, who's going to run you through our Jenkins plugin workflow.
Thanks, Taylor. Where's the... Okay. Okay. Yeah. Okay. Hey everyone, my name's Ivan, and I'm the one responsible for all the bugs you're gonna encounter in our plugin. So before I begin, I want to learn something about you. How many of you need to build iOS or OS X applications? Okay. So I can say now that Orca will make your work very easy. Why? Well, we can create a new OS X machine very easily, and you can run your builds there. But here's a question. How can you do that in a modern CI/CD environment using Jenkins? Well, ever since day one, or should I say day zero of Orca, you could use the Orca CLI to spin up a new OS X machine, and then you could use the Jenkins UI to create a permanent agent from that machine. Or, if you're like me and prefer to automate things, well, you could automate the creation of that Jenkins agent via the Jenkins CLI. However, this is far from ideal. Why? Well, firstly, if you're going to do that manually, this is very tedious and error-prone, and it definitely doesn't scale. Secondly, you still need to use two tools to do your job. You still need to configure, debug two tools, and this being the Jenkins and the Orca CLI. Furthermore, if at some point you decide you need to scale your agents, you won't be able to do that manually, and if you're gonna automate that, well, the logic, the implementation of that auto-scaling is not that straightforward. So having that in mind, and that being the goal of making our customers more productive and letting them focus on delivering value to their own customers, we decided to create the Jenkins plugin. It provides you with the following functionality. You can create two types of agents. The first type, per user request or permanent agents. These are similar to the SSH agents you create today. And the other type of agents are on-demand or ephemeral agents. They will be created on demand, and once no longer in use, they will be deleted. Let's go back to the per user request agents. When do you need them? When do you gonna use them? Well, if you know how many agents you're gonna need, these are the right agents for you. Let's say you have a few builds per day, and you never run out of agents, so your builds never wait for free agents in order to execute. And scaling doesn't make much sense in your context. The drawback here is that the resources that are being used by these idle agents, well, they can be utilized elsewhere. And if at any point you decide that you need to scale, this won't be very easy. That's why we give you the ability to create on-demand agents as well. You need those agents when you need a dynamic number of agents. You don't know how many agents you're going to need. You have thousands of jobs per day, and you very often run out of free agents. So your jobs need to wait a lot of time before they can start executing on some of the agents. That being said, scaling is a must for you. The drawback here is that the initial agent startup time could be about a minute. So let's go direct to the demo and demonstrate you how the pooling works. Okay. Okay. So this is my Jenkins. Come on. Sorry about that. Can you see good? Okay. So this is my Jenkins. I have one job here. And as you can see, I have no agents. So the first thing that I'm going to do is I'll configure Jenkins so it can create agents on demand. This is done via the configure system screen, so let's go ahead and do that. Main Jenkins configure system. At the bottom of the screen, there is a add new quote functionality. So I'll click that and select the orc quote. The first information that we need to fill here is the connection information. Why? Well, the plugin uses REST API to connect to the Orca environment, so you need to provide, well, the name doesn't matter, but you need to provide your credentials that are used to authenticate to the REST API. And you also need to provide the endpoint that we use to call the REST API. The next thing that we need to create is to add an Orca template. An Orca template is actually the agent template that Jenkins is going to use to create new agents on demand. So let's go ahead and do that. The first information that we need to provide is the VM configuration. The VM configuration is basically the VM template that Jenkins is going to use to deploy new VMs in the Orca environment, and I have none. And I don't want to go to the Orca CLI and create a new template, so I'll do that from here. I'll give it a name. Let's say it's Jenkins Word. I select the base image. Give it a name. 12 CPU is fine for me. And the agent uses Jenkins uses SSH to connect to the machine and make it an agent. So I'll provide my SS credentials. In case if anyone is wondering, yes, the password is admin as well. Please don't hack me. And this is the standard Jenkins stuff that you need to configure for every agent, number of executors. So I won't go into details here. The interesting part here is the idle termination minutes. This is basically the time of inactivity after which Jenkins will automatically delete the agent and free up the resources used in the Orca environment. I'll give it 5 minutes here. Now I'll apply my changes, save them, go back to the main screen, run the job, and see what happens. Okay, I'm going to run the job. And as you can see, it's still waiting for a free agent. So it's going to take up to a minute for the agent to appear and start executing the job. While we're waiting, I'll show you how to create a permanent agent as well. This is done the same way you create SSH agents via the Add Nodes screen. So let's go ahead and do that. Manage nodes, not add. So I'm going to add a new node here. The new option available is agent running under Orca MacStadium. So I'll select that and give it a name. As you can see, the on-demand agent is already created and it's currently being configured, but we'll go back to that later. Now, if this screen looks familiar, like the on-demand agent one, it's because it's almost the same configuration, so I won't go into details for every part of the configuration. Again, I'll need to provide my connection information here. Now, the node part, we didn't see it in the on-demand agent part. Why? Well, because actually this is the node on which the VM is going to be deployed. The on-demand functionality chooses a node automatically for you, but since you're creating permanent agents here manually, we decided to give you the flexibility to choose one of the nodes. Don't worry about going to the CLI and checking out which node has enough resources. You'll be provided only with nodes that have enough resources here. So I'll select MacPro 3. And remember the configuration that we created, the Jenkins root configuration, it's already here. So there's no need for me to create a new one. So just use it again, admin, and the standard Jenkins stuff. I'll save it, go back to the main screen. Actually, during our configuration, the on-demand executor has executed the build. As you can see here, it was successfully executed, and in about 5 minutes, it will get deleted. The permanent agent will also take about a minute to configure, so I won't wait for it. I'll just show the works, and let's hope it does what it says it does. So it has deployed the VM and will any minute start connecting it with SSH. Okay, it's connecting. Because we're not going to wait, the last thing I want to share with you is, as Chris said, the plugin, as every other Jenkins plugin, is open sourced. So if you're curious about the code or you have ideas you want to contribute, just feel free to jump to the GitHub repo, give us ideas, give us feedback. It's highly appreciated. And yeah, I'll give the word back to Chris now.
Thank you, Ivan. I appreciate it. Let's get this. So how do you get this off the screen? There we go. Thanks. So I think you guys have seen today, we basically took bare infrastructure, spun up a Kubernetes cluster on the fly, did it all with single commands, did it with UI, threw a Jenkins plugin on top of it, built it 2 different ways, both ephemerally and fixed, and did it fairly quickly in the time of this talk. But what this adds up to is making MacStadium and your Apple infrastructure a lot easier to automate and a better experience for your development team. Again, if you can imagine those single commands integrated into any kind of build or scripting process you want, or the Jenkins plugins just running your pipelines and keeping everybody focused on code. So it takes a complex experience with Apple hardware and turns it into something simple. And we just want to iterate these points too, that whether you're really strong with Kubernetes or you want to use it but you really don't know what you're doing, there's both ends of the spectrum there in this product. The CLI that Taylor showed is driving full Kubernetes clusters. It's creating pods. It's creating ingress and egress rules on the fly dynamically for you without you having to specify all that. But if you're a Kubernetes expert and you really want to jump into the sandbox yourself and hash out those details, that space is there for you too. We have a lot of customers, and I'm sure a lot of you are this way. There's security concerns about where the code repositories lie, or if Jenkins master is on site versus in the cloud. That sandbox space gives you the opportunity to create mirrors and proxies and dynamic tunnels and things like that that can solve those problems for you. So you can put command and control there, or you can put repositories or things like that. It's really quick to learn. We have great docs to kind of walk you through it. And as Taylor alluded to before, it sort of comes in the 3 flavors. The assumption is that if you're really unfamiliar with things, you might want to start with the UI. It's kind of self-instructing. The buttons kind of execute multiple CLI commands to get you where you need to go. And then once you get comfortable with that, you can jump into the CLI and do it yourself. And further still, if you feel like there's something that we're not addressing in those 2 areas, A, let us know and we'd love to fix it. But B, you can gear it towards your own workflow and your own style with our REST API. That's actually delivered via Postman, so you can run simulations against it before you actually go diving into building the code for it. This is super integrated. It makes it easy, and we hope you guys enjoy it. If you want to learn more or talk to these guys, we're going to be at the booth 1329 in the expo right after this. And we'd love to really dive down with you into specific use cases if you have detailed questions. And like I said, you can actually get started with Orca right now. It's GA, so go to macstadium.com/Orca and check it out. While you're there, go to Orca Docs. That literally has a detailed architectural overview as well of all the command sets. It shows you the CLI, the UI, and the API. You can get very familiar with it. Ivan's got our plugin up on plugins.jenkins.io/macstadium.orca. You can go look at the code, see how it's driving everything, try it out. And feel free to contact us at orca@macstadium.com if you want to talk specifics about getting an environment set up. Right now, I think we have a minute or two for questions. I'd love to answer them. Yes, sir. Okay. Okay. You want me to take it? You want to take it?
First one I think is more related to the Jenkins plugin.
Actually, more the Orca architecture is the VM container really. So
for that, your first question around imaging, right? It's a bit of a hybrid world. So we are instantiating macOS in a Docker image. But the way that works is we sort of fractionalize your image. So your base image that you're creating with Packer and uploading, that resides on NVMe flash storage. And then when you run the running builds that are containerized, that's a differential of that base image. So it's much lighter weight and containerized and running on host. And then, as Taylor said, you either destroy that ephemeral container or you commit or save it back to storage and add base images and changes there. So it's not a featherweight Docker container like you would probably be used to on the Docker side of the world, but it is a much, much lighter weight container than a VM traditionally would be. So that's the first part of that question. Then the second part was around Packer and being able to upload images. And I guess, why don't you talk through how we take images into Orca?
Yeah, so currently we have one route for VMDKs from VMware, but as long as those images can be converted to RAW or QCOW2 format, we can work with any kind of disk image media. And you have the ability to upload those through the API. So right now, the best way to do that is to use our ISO installer, which is generate an image of the size of your choice and then attach the installer media and automate that way. Beyond that, there's not a software automation piece for installing software.
Thanks. Yes, sir.
So for the plugin, does it make sense in the OS X build environment to have more than one X? Like, could you enter more in there and have that work?
yeah, you can have more expert as well. I mean, yeah.
I think it kind of depends on your build considerations for the code you're running, but you can definitely run more than one. Great. Anybody else? Cool. We certainly appreciate you guys coming out. And again, if you'd like to talk to us further, come by the booth. Thank you for your time.
For sure.